Good day, class. Alan here, coming at you with another rendition of right triangle trig. We're going to be talking about solutions and applications of these in a little bit different format. So here we go. Just to highlight some of the things that we'll be talking about in this section, we're going to introduce these things that many of you in the sciences will be familiar with. They're called significant digits or figures, sig figs. Many of you know them for short. And so we're going to be asked to use these when approximating answers and making sure that we don't give any more exactness of a scenario situation than we should. And so just to give you a quick little story of how this has been done in the past is the average human body temperature, many of you know as 98.6 degrees in our American form of Fahrenheit. Most other countries use Celsius, which is a much smarter way to use, but I won't get into all of that. So what happened was another country wanted to know what the average human body temperature was, and so they took a bunch of people's temperatures, several thousands, and they then averaged them out, but they all measured them in Celsius. And the way that they measured them in Celsius was to just the nearest whole number, so 2 digits. And unfortunately, when they went to convert that, they actually, when changing it over to Fahrenheit, took it to another significant figure or digit and put 98.6, when in reality they should have only provided 2 digits. So for us, the average body temperature should actually be approximately 99 degrees. So if you're a little bit above 98.6, don't freak out. That 0.6 actually shouldn't even be there when they converted it over. So again, these are the types of things that we need to know mathematically so that we don't actually provide more details like the 0.6 when in Celsius they only did 2 digits. Then they should have only been allowed or reported to 2 digits. So either rounding that up or down to 99. Okay, so when dealing with these things, we're going to have several different looks. All right, so I have some definitions and things that you can pause the video and read through them, but I put these on here for you. I'll just quickly go through what it means when we're given 62 or 36 degrees. Then obviously that's only 2 significant figures or digits. But when we're given something like 60.4, that's also, again, obvious that it's 3. 71.25, obvious that it's 4. 21.264, 5, because there are literally that number there. But some of the ones that are a little bit trickier that students struggle with is 52 degrees and 30 minutes. A lot of people will see 4 digits there, and you're absolutely right. But that 0 means that it could or could not represent that 4th digit. And so we can't assume that it is. So oftentimes there's going to have to be other data that is there. And if there are 3 anywhere else, then that's the least amount of digits that they gave us. We can't provide any more, even if we have 4 in other places. Okay, so be very careful with that. Same thing with the next one, 81 degrees, 48 minutes. That obviously has 4, no ifs, ands, or buts about it. But if we wanted to work backwards and give them just 3, then for that one, we would have said 81 degrees and 50 minutes, because we're taking the 8 and rounding it up to the next highest digit, the third, 1, 2, 3 significant figure. Okay, so again, be very careful with these. Last one I'll just try to hit home is this one here. How many significant digits are there actually? 1, 2, 3, 4, 5, and maybe 6. So again, with this one, we're saying there's definitely 5, but maybe 6, depending on all the other data that is provided. Okay, so just to hit that point home once more, cannot be any more accurate than the smallest number. They're saying the least accurate number given. So if one has only 2 digits and the other have 3, we can't give them to 3 digits. We'd have to do it for only 2. So the other part of this section that we're going to be talking a lot about is when solving equations. You guys have probably heard of that before, but now we're going to be solving triangles. And so what does it mean when you're asked to solve a triangle instead of an equation? Well, what did it mean to solve an equation? That was to get the solutions or answers for it. Well, to solve a triangle means to do something similar. But now you're going to be asked to find all the angles and the sides of that given triangle. So to solve it means to find everything that is not known that was given to you. All right? But again, these go hand in hand. To maintain the accuracy of our answers, we're going to use the given information and not anything that we found, if we can avoid it, because sometimes we do make mistakes, right? We're human. That's how we learn. But that requires us to then use the given information as much as possible so that if we did make a mistake, we don't make continuous mistakes with all the other things. And then the other thing that students often make mistakes with is rounding too early. Even though they may say round to the nearest 2 digits or third decimal, don't do that until you are providing them with the final answer. Because if you round within other calculations, then all of those are also going to be rounded, and so it'll be off, depending on by how much they're asking you to round by quite a bit. All right. So we talked about in the last section, the last video, about inverse. And the inverse was used when we were asked to find an angle. And when we were given a trig with an angle, we gave them that ratio out, or that length, whether it was as a fraction, a ratio, or in that decimal form. All right. So use these to try to remember. Inverse gives you angles. That's what it finds for you. Where the trig gives us that ratio, that length that we're dealing with. So if you just have the trig function there with the angle measurement, then you're going to give me that ratio, that length. But if they don't give you the angle and you're asked to find that, then you're going to have to use the inverse, which, remember, whether it's sine, cosine, or tangent, it's that little -1 exponent to find that angle. So many of these problems are going to look like word problems, and what we're going to be really tasked with doing is taking this short paragraph or words and making it into something that we can actually solve. All right? So my advice to you is draw a sketch of what you're given. And most importantly, make sure you label it correctly. All right? If you don't do that, then it's going to be very difficult for you to actually solve the problem correctly. You may have the right answers, but in a different order, which means it's wrong. All right? So here's a nice little tool to try to help you remember, all right, what you should be doing. You don't have to use this, just a suggestion, but draw it. And again, label it correctly. And then use that drawing to write an equation so that you can then solve the equation. And don't forget, make sure your answers make sense. Okay? So one thing that we're going to be seeing pretty frequently in this section are things called the angle of elevation and the angle of depression. Elevation meaning up, elevate, elevate, right? And then depression meaning you're down, okay? And that is always going to be with the line of sight or horizontal line. So when we're talking about that, we're always looking from some point horizontally at our line of sight, straight forward. And if it's an angle of elevation, then like we said, of course, we're going to be going in the upwards, positive direction. Angle of depression going downwards from that horizontal line. All right. So when drawing these, again, they're going to be throwing a lot of words at you, being able to first draw to see what you're dealing with, labeling it correctly, and then setting up some equation to solve the question at hand. Those are our tasks and our goals for this section. So let's start with this first example. It asks you to solve the right triangle, that's important, ABC. And if you remember from previous sections and videos, we talked about the right triangle being labeled in any form as long as the right angle is C. Okay? And then opposite that angle, there's a side that this angle creates based off of the two sides that create the angle. And that would be this third side called the hypotenuse. And remember, all of those are going to be the lowercase letters for the lengths. So whether you call the top left one up here A or the bottom right A, it doesn't really matter. Just make sure your drawing is true. That if I call capital A up there for that angle, then opposite that would be little a, capital B here would be little b. And so I'm just going to start labeling what they've given me. And they told us that angle B, using the capital letter, is 28 degrees, 40 minutes. So I'm going to go ahead and label that right here at angle B, 28 degrees, 40 minutes. And little a is 25.3 centimeters. So I'll go to length A, which is that lowercase letter, and put 25.3 centimeters. So before we actually start attacking this problem and solving it, how many sig figs should we be supporting our answers and supplying them with? Well, definitely there's 3 here, but there could be 4 here. But because there's only 3 here, that means we're only going to count this as 3 sig figs. Okay, so when giving our answers for all the other angles, which by the way, we only have 1 unknown angle, and all the other side lengths, which we have 2 of those, we are going to supply them with 3 sig figs. So how are we going to find angle A? Let's start with that. Let's start with the inside for this one. Well, hopefully you recognize that because this is a right angle, we know that the other 2 angles, A and B, are complementary angles. Because we know the sum of the triangle is 180. So we already know since this one right here is 90, the other 2, angle A plus angle B, have to equal 90. So all we have left to do is solve that by subtracting 28 degrees, 40 minutes from both sides. And that will give me the measurement of angle A. Now remember we did this previous section. We're going to go ahead and borrow one of these degrees. So now I'll go down to 89 and I'll write it as 60 minutes. So that is still a sum of 90 degrees up here because 60 minutes, remember, makes 1 degree. But we wanted to be able to subtract the 40 from it. So that obviously gives me 20 minutes. And then 89 minus 28 would be 1 and 6. So that is our answer for angle A. And did I supply them with the correct number of sig figs? Yes, still 3 technically. Good, so we got all our angles. We're on our way to solving the triangle. We got the inside parts, but what about the outside? Well, remember that 61 degrees, 20 minutes, I could have made a mistake, so I'm not even gonna write it in up here because I don't wanna use it. I wanna use the things that they did give me. That includes this angle and this side. And because it's a right triangle, then I can use my trig. So let's start with finding the next letter in the alphabet, lowercase b. And if I'm using this angle, that would be the side opposite of it. And then I'd have to use the side adjacent because that's the other one I know. So what trig function would I use for opposite and adjacent? Hopefully you all said tangent. So the tangent of that angle B, which we know is this, would be equal to the opposite side over the adjacent side. And I'm going to let you in on a secret here. Mathematically, we can only ever solve an equation that has one variable. If there are two variables, then we need a second equation with those two in them. Three variables, three. So we want to make sure that we get it down to one equation with just one unknown. And if you notice, it would be very easy to get that by itself. Because it's being divided, we'll undo that by multiplying by 25.3 to both sides. Because then that would cancel that out to be a 1, and we'd be left with our lowercase b. All we would have to do is punch that in our calculator, and I'll let you guys do that real quick and come back and see what the answer would be. And you should have got 13.83222071, so on. Now, obviously we said that we would only be giving 3 significant digits. So for this, we should be looking at the fourth one and then seeing what we're going to do with that third. So in this case, we will put 13.8. And then what should our units be? Now, I didn't write them in there, but this would have been centimeters. We did include the units here. So when we multiply that over, and this gave us some number, well, when we multiplied this out and got just digits, and we multiplied it by the 25.3, which, by the way, that would have been the order that you should have done that, multiplying in your calculator. Do the 28 degrees, 40 minutes of tangent, find that number, then multiply it by the 25.3, which is in centimeters, and that therefore would give us a length in centimeters, which is what that should be, since that's what this should be. So if you want to just put those in now, that's fine. How are you going to find little c? Again, please try to use the given terms. So in this case, they gave us this angle B, they gave us this. Even though we know this now, I'm going to use the adjacent and the hypotenuse. So for me, that would be using cosine of our angle 28.66666 degrees. And that would be equal to the adjacent, which is 25.3 centimeters, over the hypotenuse, which is always opposite the 90. So this one requires a little bit more work to solve. We're going to have to multiply by the c to both sides to get rid of our fractions. And then that leaves us with that lowercase c side that we're trying to find times the cosine of our 28.6 repeating. And now it's equal to 25.3. But in order to get that by itself, we're going to have to divide both sides by that cosine. That then cancels this out, and I have the lowercase c that I was trying to find. It would be equal to whatever that is. So punch that in your calculator, make sure you get the right answer. And again, even though you should have got 28.83436 ... remember, we're only taking it to the third significant figure or digit. So when we look at the 3, we're going to keep it at that and say it is 28.8. And now we have all of the sides and all of the angles for this specific triangle that they asked us to solve for. Okay? So where can you go wrong? Everywhere. Look at all the calculations and things that I made. So be nice, neat, and organized. Be very careful when writing these things down and doing any conversions or working things out on your calculator. I don't like calculators. They're never wrong. The user is, though. So whatever you type in, it's going to do it correctly, but what you typed in may not be in the correct form. So be very careful.